Hey, good morning, CCTI, pre-calculus classes. Mr. Pashar here once again. I hope this second video finds you well. My goal today in this video is to show you just a few more things on exponential equations and then begin discussing how do we solve logarithmic equations. And again, it comes down to using your properties. So what I plan on doing today is using some of the lecture note material on the board here for you, and hopefully that'll help you navigate through that homework assignment, which is due on Monday. Again, just do a little bit every day, take your time, you'll get through it. And remember, check your answers in the back of the book. That's why I give you the odd ones. So I want to start off with looking at an equation like this one. E to the 5 minus 3x power equals 9. Now, how do we handle one like this? Well, if you remember from the video from yesterday, if you have a base E, what we should do is take the ln of both sides, because the ln will free this exponent to come down in front. So let's take the ln of both sides. So you have ln of e to the 5 minus 3x equals ln of 9. So that means we have 5 minus 3x is freed, the ln and the e is gone, and that equals the ln of 9. Remember, ln of 9 is just some wonky type of number, so we just solve this equation like normal. Think of this as like number 9, even though it's not precisely 9. I'll go ahead and subtract 5. So I have negative 3x equals ln of 9 plus a 5. And then what I'll do here is divide both sides by a negative 3. So x is going to be the ln of 9 minus 5 over negative 3. And guess what? That's a totally fine answer. You can use your calculator to get a decimal, but that's totally fine. But I think the back of your textbook, they use decimal answers, so you just want to go ahead and confirm that when you're doing textbook exercises. Okay? So that's how we solve one like this with base E. So again, I would do at this point to go back and see if you can solve this equation, and I will be back. Okay, welcome back. So now we're going to talk about logarithmic equations. And the way that we work with log equations is very similar to exponentials. You want to use those properties that we have. Now the thing about log equations is this: you need to check your answers. You have to check your answers when you're solving log equations, because sometimes the answers we get are extraneous, meaning they don't work in the original equation. But here's one from your lecture notes. We have log base 7 of x equals 5. So what's our plan of attack here? Well, what we want to do is incorporate this base 7 log somehow in the problem solving process. So what we do is, we remember we have this property that says if you have b to the log base b of x, that's just x. So in other words, if we raise both sides by 7 and have the log as the exponent, that will free this x to drop right down in front. So let's do that. So we have 7 to the log base 7 of x equals 7 to the 5. And when you do that, this gives you what's up here, which is the x. X equals 7 to the 5 power, and that's a rather large number. That's 16,807. So this is a pretty simple log equation to solve. Again, we use the base Down here, raise it up to that log. Take this number on the right hand side equals, raise that up by 7 as well. And then we get our answer. So this isn't too bad. But you do need to check, and I'll always leave the check to you for the most part, just to save some time. But how do you check it? Well, you take this number and put it in here. So, is log base 7 of 16,875? Of course it is. So that's how we do it. So that was example 1A from part 2 of your notes. Let's look at one that slightly a little more detail. This is example C from your notes. Log base 4 of x plus 3 equals 2. So we want to use the same idea, of course. What you want to do is take this 4 and incorporate it into the problem. So that's going to be 4 raised to the log 4 of x plus 3 equals 4 to the 2. And again, when we do this, we have the same bases here. So essentially all this goes away, okay? And you're just left with the exponent. So x plus 3 is 4 squared, which is 16. Subtract 3, you get 13. So the solution for this one would be 13. And if you do check, you will see that that does work out. 13 plus 3 is 16. Log base 4 of 16 is 2. That's absolutely true. So I would encourage you at this point maybe to pause this video, to go back and maybe do this problem, the one before, and I'll come back to you in a moment. Okay, so hopefully we're pretty good on those two. So let's look at one that involves an ln. How do we solve something that has an ln? So this is letter D from your notes. We have 3 times the ln of 2x equals 12. So 3 times the ln of 2x equals 12, okay? What you want to do here is first get this 3 out of here, because this isn't going to help us. Anytime you have a number multiplied onto an ln, divide it away in this first step. So that now leaves us with the ln of 2x equals 4, so that's much better. Now, our game plan here is if we have an ln, so a natural log, we want to do the same thing we did last time. Remember that the ln has that little invisible base e that we don't write, so that's what we're going to do. We're going to raise it by e. So we're going to say e to the ln of 2x equals e to the 4, because the property says e to the ln of x is x. So if we apply that property here, it's going to free the 2x down below. So this is going to be 2x equals e to the 4, divide by 2, x equals e to the 4 over 2. And again, you should check this to see if it works in the original equation, but it does. So e to the 4 divided by 2 is the correct answer. Or again, if this was a textbook problem, you might want to check for the decimal. Okay? But this is how we do it. So we got the 3 out of there. We bumped up by e on both sides, and it's solved for x. So that's one situation with an ln. Now the next type of log problem that we're going to see is one in which we have to do some kind of condensing, because we don't have any rules. If you look over your notes, there's no rules that allow us to handle when we have two logs on one side of an equal sign. And there will come a point where you're going to have logs on both sides of an equal sign, and that'll be in an upcoming video, but we won't do that one right now. But for now, we're just going to look at the situation where we have to condense, okay? And I did send everybody a link to a video that shows this, so I'm hoping that you did watch it. But this is example F from your notes. We have log base 2 of x plus log base 2 of x minus 7 equals 3. So this is a classic type log equation. The big thing here is you need to condense. You gotta condense, okay? So we gotta get these two logs down to 1, and that's why I taught you that stuff a few weeks ago. You know, smart thinking, right? These are things you're gonna need to go forward, right? So before I do this, does anybody know how you condense that? Does anybody know how you condense such a thing, log base 2 of x plus log base 2 of x minus 7? You should know how to do it. Yes, no, maybe, who knows? Well, remember that addition means multiplication for logs. So what we have here is log base 2 of x times x minus 7. So that's how you condense the left-hand side. So now we want to apply that property we did before, where we look at what the base is and we essentially bump up by that base. So we're going to write this as 2 raised to the log base 2 of x times x minus 7 equals 2 to the 3 power over on the right hand side. Okay, so let's just take a look, make sure you understand that. Again, the whole idea is they get the same bases here, right? That's the whole idea. And now we're kind of in good shape, because now what we're going to do here is this, drop this down. So you're going to have x times x minus 7 equals 2 to the third, which is 8. So now you go ahead and distribute. This gives you x squared minus 7x equals 8. Now, x squared minus 7x equals 8. This should look familiar. This is your quadratic equation format. And in order to solve a quadratic equation, remember what has to be done. You want to set this thing to 0. So this 8 has to go over here to the left. So we've got x squared minus 7x minus 8 is 0. So this is the equation we got to solve. We get kind of spoiled. Most of the examples that we do are linear, right? So it's very easy. They're very sissy type equations, but you got to remember how to do this, which you're all very capable of in the pre-calc world. 3 ways you could solve it: factoring, complete the square, or quadratic formula. But always do yourself the favor of trying to factor first instead of always running to the quadratic formula. So I think that we could solve this using the factoring. X and x, of course. Factors of 8, either 8 and 1 or 4 and 2. 4 and 2 is not going to help us here, so I think we're going to go with 8 and 1. The middle term is a minus. That means the bigger these two numbers have to hold the minus. So I think this is the configuration that we want. Set both of these factors equal to 0 and solve them. So we get x equals 8 and x equals -1. So we get two answers, No surprise it's quadratic. Now, this is where it becomes important to check your answers, because now especially we got two of them. Sometimes both answers work. Sometimes one of the answers works. Sometimes none of the answers work. So you have to check. Go back to the original. If you start with x equals 8 and you plug in 8 here, log base 2 of 8, that's going to give you 3. And if you plug 8 in here, that's going to give you 1. So this is going to be a 0 for the answer. And this is going to be 3. 3 and 0 is 3. So we know that this answer is good. Now we plug in -1. But think about this. We don't have to do much work here, because right away, if you plug in -1 here, log base 2 of -1, that doesn't exist, right? We can't have that. Logs cannot take on negative values. So we throw this answer out. So therefore, your solution set for this equation is just going to be the number 8. So again, the importance of being able to check your solutions. Okay, so I hope this video helps you out a little bit as you go and navigate through your textbook exercises. Again, feel free to call or email between 11 and 1 if you have any questions on any of the material. And again, I hope everybody is doing well today. So until next time in another video, Mr. Pashar here signing off. Enjoy the rest of your day. Stay safe, stay healthy.